So we've been talking a lot about sequences. Now we're going to talk about series and what that is. So we're going to do both together. We're going to do an arithmetic and geometric series. What we mean by series. So when you see the word series, first thing that pops into your head is probably the Toronto Blue Jays, who won the World Series in 1992. Yeah, that's pretty common. A lot of people guessed that, which is great. That was an awesome, that was awesome. Blue Jays, go Blue Jays. But seriously though, you probably don't think of that. You probably, you guys watch like Netflix, and my daughter's watching this show. It's called Outside, something with the banks, Outer Banks. That's pretty, yeah, kind of a cool. I watched a couple episodes. It's pretty cool. Some kids in some boats, and there's some gold. So I don't know. It's kind of neat. Anyway, yeah, that's what you probably think of a TV series. But actually, we're going to use that that word series and look at it mathematically. So a mathematical series is what we call the implicated sum. Now this is a little bit weird. It's a notation thing. It's the implicated, means it's implied, sum of a list of numbers that are generated, generated according to some pattern or rule. So for example, 1, 3, 5, 7, 9. This is what I mean by a series. So the difference before, a sequence was 1, 3, 5, 7, 9. That was a sequence. A series is 1 plus 3 plus 5 plus 7 and plus 9. That's what we mean. So it's a very subtle difference. Now it's also interesting that these are additions, so that means add them up. And we could actually add them up. We could get an actual sum of 25 if we added just these, if I just stop there. But that's not a series, okay? The sum isn't a series. It's just this implicated means we're about to, or it's implied that we're going to add them up. Now, of course, the challenge is we're going to have this dot, dot, dot down here. So this is going to keep going and going. So finding the sums of a series with only a few terms is easy. So imagine these terms here, 10 plus 20 is 30. 30 plus 30 is 60, 70, 80. Yeah, what is that? Let's try it again. Sorry. That's 30, 60, 75, 100. Yeah, it hits 100. Sorry. So the actual sum is 100. As the number of terms increases, though, of course, there has to be a more efficient way, and of course there is. To find the total, I'm going to create an arithmetic series and look at it. So I would have these things added together. Yep. Good. I would have them added together. I would hit 100. This is what my series looks like. This is the actual sum of the series. Now the quicker way, which is actually kind of interesting, is I'm going to find the mean of the first and last term. So I have the first term here, the last term here. I add them up and divide by 2, and that gives me 20. And then I'm going to multiply that 20 by the number of terms. So 20 times 5, which gives me 100. Which is actually pretty amazing. So let's take a look and see what's happening with this. This is sort of our technique and how we're going to do this. So here's our terms here. That when we add them up, I take the mean, 20 times it by 5, that gives me 100. So why don't we look at this in terms of a graph? Okay, imagine these are a bar graph, and these are the amounts that I had. And 20 is the mean, 20 is the middle. So that the third term is sitting here at this line of 20. Well, when I'm finding the mean, these are the 5 terms. When I'm finding the mean, what I'm doing is I'm taking this 25 and I'm taking this chunk of red basically off this part, and I'm throwing it down here on this part. Okay, and I'm taking this larger chunk off the 30 and I'm throwing it down here on this part down here. And then I'm saying they're all basically 20, and there's 5 things, 1, 2, 3, 4, 5. So they're all 20. If I add them all up, I get to my 100. That's what the formula is sort of doing, which is kind of interesting. Now, if we extend this approach to the general case, we're going to be able to generate a formula that's going to allow us to find the sum of any series. So this is going to be our formula for the sum of an arithmetic series. Really, it's the mean of the first and last term times the number of terms. That's our general structure. So the first term is A. The last term is going to be, we don't know what it is, so t subscript n divided by 2 times it by the number of terms. Now, we have this formula for t subscript n, the term formula. So what I'm going to do is I'm going to substitute this t subscript n in for my t subscript n here. And it's going to look a little complicated when I do it, but I just want to point out all I've done, and here's my A. My A is still here. My A is still here. My N is still here. N is still there. The divide by 2 is still there. Divide by 2 is still there. All I've done is replace this part with this. A plus n minus 1d. A plus n minus 1d. That's all I've done. And now I can simplify this. I have A and A, which is 2A. That's easy. I'm going to pull this n out front just for notation. And I'm going to write it like this. So here are my two A's here. Here's my n out front. This is the formula for the sum of an arithmetic series. So let's try an example. 2, 4, 6, 8, and 10. I know the sum is 30. I mean, I can work it out by hand. But let's just try the formula here. Okay, n is 5, so number of terms, 1, 2, 3, 4, 5. 5 terms. A is 2, first term is 2. And I'm adding 2 every time, plus 2, all the way down. So I plug all the numbers in, and really now just an issue of order of operations. 5 take away 1 is 4. 4 times 2 is 8. 2 times 2 is 4. Now I have 12 times 5 over 2. 60 times 5, sorry, 12 times 5. 12 times 5 is 60. And 60 divided by 2 is 30. So the next kind of question, sorry, that was a little too quick. So the answer there is 30. There's our answer there at 30. So the next question is going to be, I'll find the sum, but I don't know how many term numbers I have. I don't know n. Okay, I'm not sure. I have the first term, the second term, the third term. I have these dots here, dot, 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 and then I have, I don't know what that is. I mean, I could work it out by hand, but I want to, find a quicker way. I know A, -4. And I know D is -6, my common difference. I'm adding -6 every time. But I want to figure out n. So to do that, I have to go back and use the term formula. So there's going to be 2 steps on this. I'm going to be using 2 formulas. So I'm going to go back to the term formula, and I'm going to plug in -94 as my term. I know A was -4 and D was -6. So we saw this before. So here's my -94 in for my term. And now all I have to do is solve for n. So same thing, distributive property, get rid of the brackets, collect like terms, and then divide both sides by -6, and I get n is equal to 16. So then I can go back now and actually figure out my sum, because now I know what n is, as 16. So I plug it all in, and again, it's order of operations here. 16 minus 1 is 15, times -6 is there. 2 times -4 is -8. I plug everything in, and I get a sum of -784. That's good. Take a look at page 400.